All right, so we're almost done. Just one more little thing to talk about, and that's an idea introduced by Joseph Fourier, who lived in 17 and 1800s. And it kind of is the reverse idea of what we've just seen, where we can add together sinusoids to give us a more complicated periodic structure. And what Fourier realized was that if you have any repeating wave with any kind of weird profile doing any kind of crazy thing, then in fact you can build it up by summing sine waves which have the same period as the wave, half the period, a third of the period, and so on. And you just keep adding more and more sine waves of decreasing periods, and eventually you're going to get something that basically mimics the crazy original thing. What does this look like? Well, here we've got some examples, so let's just talk through what's going on here. So imagine that what we actually want is what's called a square wave, so a wave that goes straight and then down. Well, one way to approximate that would just be with a sine wave that goes up and then down. And actually, for some things, that's not very bad at all. It might be good enough. But if you need something that has a more abrupt start and finish, then you could, for example, add another wave. So if you look at this yellow line over here, that's probably the sum of two sines. So this might be, that's not a great color. We'll do sine of omega 1t plus sine of omega 2t, and maybe a phase angle. And so you'll end up with this yellow shape, which is slightly better. And the more sinusoids that you add together, because remember we've said with Fourier that the second angular frequency will be twice the first. By the time you get to, for example, this third wave over here, what you've probably got is sine of omega t plus sine of 2 omega t plus sine of 3 omega t plus sine of 4 omega t. And you can see that that blue wave is actually starting to do quite a good impression of a square wave. You know, it's got quite an abrupt up and then not too wavy on top and then an abrupt down. And that's the general idea behind Fourier series, because it turns out it's quite easy to generate sine waves, but it's hard to generate things which have a different kind of profile, like a square profile. So by adding together bunches of different frequency sine waves, you can actually approximate pretty much anything that you want. So you can have a look at some of the others. There we go. All right, so let's just have a quick summary. What did we do today? Well, we talked about vibrations and pointed out that almost everything can vibrate, so it's kind of an important thing to understand. And in order to understand it, we developed a mathematical way of analyzing vibrations. And then we decided that one vibration wasn't enough, so we looked at what happens when you combine vibrations. And that led us to talk a little bit about the concept of beats, and then just a little word on Fourier and Fourier series. Important equations, well, possibly the most important thing to take out of this is our solution to our differential equation describing simple harmonic motion. And remember we said we just happened to pick a sign, but it could have been a cosine, and as you saw later on, actually we kind of work with either of them. If you have simple harmonic motion, which has an amplitude of A, angular frequency omega, and a phase angle of phi naught, then we know that the period, so the time it takes for our sinusoid to make one complete oscillation is 2 pi over the angular frequency, and the frequency is 1 over the period, which is the angular frequency divided by 2 pi. So those are all pretty important things. When we started talking about beats, and this is also an important thing, we saw that we could actually, assuming that the two frequencies are close together and the amplitudes are close together or the same, we could describe motion using this equation over here. And really, what this gives us is a modulated amplitude. So modulated just means that it has its own frequency. So that's really an amplitude, and over here is the actual frequency of the resulting function. And there we go. Thank you, well done. We're done for the day. So spend some time working through the problems, and then we'll see you in the tutorials.